Hey chemistry folks, this is Miss Gray.
Mr. Henderson.
And Mrs. Uy.
You now have the team of three.
Yes.
Yeah. Good. We're glad to have Mr. Henderson with us now.
I'm happy to be here.
All right, we're going to start on Unit 3. And our first podcast is about atomic structure.
All right.
You ready for this?
I'm always ready.
All right, let's do this.
Good. Okay, first, what is an atom? We need to define what is an atom, right?
Good plan.
Yeah. What do they say here?
All right.
Smallest particle of a blank that retains its identity in a chemical reaction. What do we think that would be?
That would be the smallest particle of an
element.
Right. And you'll see behind us is the periodic table of the elements. So anything that's on there would be made up of atoms that are all exactly the same kind. And we can't make them any smaller or they won't behave like that kind of element anymore. So copper is all copper atoms.
Right.
And oxygen is all oxygen atoms.
And hydrogen.
Right, and if we broke them into smaller pieces, they would behave like goofy things and not like elements anymore.
Yes. All right.
So here's a picture of what the modern understanding of the atom is like, where the nucleus in the center is made of these goofy things called quarks, and then we have electrons around the outside.
Spinning around.
Right?
Okay.
And those quarks are basically the things that make neutrons and protons. So we don't even have to know about quarks yet.
Not yet. No.
Not yet.
It'll come.
All right.
Nope.
Okay. Who suggested the existence of atoms? Like the history?
Yeah, the first guy to come up with this was this Greek guy.
Yeah, kind of old. Democritus.
Right, like democracy.
Yeah.
There you are.
Yep.
Okay.
That's somebody's
There he
idea
is.
what he looks
Now,
like.
isn't he just handsome? I'll tell you what.
Almost as pretty as me.
Well, I don't know.
I can't say anymore. I don't know what to say.
Well, his idea was that matter was made of tiny, indivisible, unchangeable particles, and that their surfaces would look different according to their properties. Like a metal would have a shiny surface, and a non-metal would be like bubbly.
A different one, yeah.
Right. And so what did he call these particles?
What did he call them?
Atoms. And he made a group of people that agreed with him, and they called them the atomists.
Sorry, my writing's terrible here.
It's okay.
It takes time to get used to the pen.
It does. So anyway, we got the atoms there.
Right. From good old Democritus. And then 2,000 years later, no, 2,200 years later.
Right. That's a little bit of time.
Right, John Dalton.
John
and there's
Dalton.
a reason they called those times the Dark Ages, between the Golden Age in Greece and Rome and the time of the Renaissance. They call it the Dark Ages because not much science happened then.
Right.
Not much of any kind of learning.
We continued believing what was already there.
That's a good history, Miss Gray.
Oh, thanks.
I'm learning from you.
Okay.
All right, what is Dalton's atomic theory?
Well, most of what he said was true. But here's one part that he suggested that we don't believe anymore, that all atoms are made of tiny, indivisible particles called atoms.
All right. When we say indivisible, what does that mean?
Oh, good question. That means that we can't break it into anything smaller.
All right.
So he pictured an atom as sort of a solid sphere.
That's a very nice color, Mr. Anderson.
Yeah, I like green, now and then we got to have that.
And atoms of the same element would be the same.
Yep.
Otherwise, they wouldn't be the same element anymore.
Right.
All right. And in the third one, it says atoms of different elements can combine to form.
What do they combine to form? You guys should know this from the last few pages. Whoops. They combine to form compounds.
And they combine in predictable ways. So they have whole number ratios, and every time you make water, it's going to combine with exactly the same ratio.
Yes, H2O.
Yes.
Right.
So 2 hydrogen and then 1 oxygen.
Right. And in carbon dioxide, it would be 1 carbon for 2 oxygens.
Or 2 oxygen.
Right.
So there we go.
Always the same ratio.
All right. And then the last one.
The reactions occur when atoms are separated, joined, or otherwise rearranged.
Yeah.
Yes.
When we talked about chemical properties and physical properties and chemical changes, this was one of the main things. The atoms are all still there, but they're bonded in different ways now.
Yes.
Right, absolutely. So,
Good.
All right,
Well,
those are
thanks.
Dalton's atomic
Dalton.
theory.
Yeah.
Yeah.
Came up with some good ideas.
Do
But
they
let's-
need to memorize this atomic theory?
Yeah, the 4 tenets of Dalton's theory are important to know, especially
Absolutely.
the part that he was wrong about.
Mm-hmm.
It's not so much that he was wrong. He was using the best information they had at the time.
Yes.
We have better information, and so now we know more about what's inside the atom.
Exactly.
So let's talk about those
All right.
particles inside the atom.
Try to remember Dalton's atomic theory. All right. How is
Okay.
an atom of hydrogen different from an atom of oxygen? Yeah.
That's a good question.
That's a good question.
Yes.
Let's try to answer that.
Well, elements would be different because they have different numbers of protons. That's what identifies what
An element.
an element is, right? So hydrogen on the periodic table has only the atomic number 1,
1.
and that tells us we have 1 proton in its nucleus, whereas oxygen has 8.
Yes.
Right. Yeah. And so it looks quite a bit different that way.
Right. Well, and oxygen is a lot bigger. It's like 16 times bigger, and if I suddenly weighed 16 times more, you'd probably notice.
Yes.
Probably would, yeah.
Right.
I think all of us, if we're going to.
Yes, we would all
Yeah.
notice if
Yeah.
anybody doubled their mass or multiplied their mass by
Okay.
16.
All right. The number of protons in the nucleus of an atom of that element. What is that?
Oh, that's what I referred to before. I said hydrogen has the number 1. We call that the atomic number
The atomic number.
because it's so handy for us to put the elements in order according to their number of protons.
Yes.
Yep. Now, normally I'd write out number, but I'm writing big. So
Right.
we
It
just put
doesn't
the
all fit
symbol.
on the line.
That's
Yeah.
atomic number.
Yes,
Atomic number.
Oops.
that's okay.
Well, I'll clear that off. Not a
All
problem.
Okay, here we go. Here's an
So
example.
Yeah, krypton. Not the same as kryptonite for
Right.
you Superman
Yep.
fans.
Oh.
No.
Okay.
Because krypton is a noble gas, of course, and so it doesn't react.
Right.
Okay.
And so the atomic number is usually on the top in the periodic table. Sometimes it's the top left, sometimes it's the center. But just look for the whole number. That's the atomic number. The one at the bottom where there's a decimal value, that's going to be the atomic weight.
atomic weight.
Right there.
So we don't want to confuse those two.
Okay, there's a question right here. How many protons does krypton have?
In our last slide, we saw that the atomic number is equal to the number of protons.
So?
So this is easy.
All right,
So we got 36.
that's the number of protons.
Yeah.
Okay, so if there's 36 positive charges and an atom has to be electrically neutral, then how many negative charges do we need?
Well, come on. We need 36 more because it has to be neutral. All the positives
Yep.
cancel out.
Oops.
So the negative particles are the electrons. Protons and electrons have to be the same
The
or
same.
it's not an atom anymore.
Yes.
Right. Or it's not a neutral atom, at least.
Yes, right.
Okay. All right, let's talk about the subatomic particles. What are these?
Yeah, well, we referred to the proton. Let's see what is a proton.
All right.
It's positively charged, so every time you see me abbreviate proton, I'm going to call it a P with a plus sign
P
at
with
the
a
top.
plus.
So now you all know
Right,
what that
so
means.
right there.
So
Yep.
it's positively charged found inside the
Nucleus.
nucleus of an
Okay.
atom.
Most of our students learned this like in 7th grade. I
Yeah.
think
Yep.
this will be easy for them.
Yeah, it's
Yes,
just
I
a
think so.
review. All right. It has a charge of, what's the charge of?
Well, if you look, we got a plus here.
Mm-hmm.
So that probably tells us it's going to be a charge of something positive.
Right.
Something positive.
And scientists have just agreed to call it positive 1.
Or plus,
Plus 1.
plus 1.
Yeah. Even though now we can calculate how many electron
Yeah.
volts and all that stuff, but plus 1 is good enough.
Okay, what about the mass?
We've all agreed to call that 1.
1.
One
One.
atomic mass unit. And see, when scientists agree to make the math easy, that's one of my favorite things about being a scientist.
Yep.
Yeah.
I like it when math is easy.
Math, it should be easy.
Yeah.
And she said atomic mass unit, we always abbreviate that scientist as AMU rather than
Yeah.
writing all that out.
Yeah.
Yes.
Yep.
Not because we're lazy, just because we're efficient.
Well,
yes.
I tell all my kids, scientists and mathematicians are lazy. When they can abbreviate, they will.
Yes. Good point.
Yeah.
And we mentioned before, the atomic number is the same as the protons? Always.
All right.
Always, always, always.
Remember that, guys. All right, let's go to neutrons.
Neutrons are called neutrons because they are neutral.
Neutral.
Right?
Neutral, yeah.
And that means they don't have a charge.
Yep. So remember the word neutral for neutron. Okay.
Yep.
And it has a charge of
No charge means
No charge means
call it 0.
0.
0. Once again, you can see that right here.
Hey,
Yeah.
it's
Look at
like
that.
it all makes sense.
And the mass is
It's the same as a proton.
same as the
So
protons.
it's going to be 1 AMU again.
And again, that makes our math easy because then to find the total mass of the atom, all we do is add up the protons and the neutrons, and we got it.
All right.
But what about those electrons?
No, they don't count.
Okay.
That's like counting all your eyelashes.
Yeah.
They don't add much.
No.
Okay, now we can't look up the number of neutrons. We have to calculate it. So, Mr. Henderson, what would you do to calculate how many neutrons are in an atom?
Well, based on what you just said, we have the atomic mass is the total number of neutrons and protons.
Right?
So I would look at that atomic mass
Mm-hmm.
and subtract the number of protons. That'll tell me how many neutrons there are.
Okay.
All right.
Will you write that formula for us so we
I
can see?
can.
We would take the
I'll
mass
find it
number.
here. Where we go.
There's your pen.
Mass number
And then subtract from the mass number
minus
the atomic number.
atomic number
And that will give us our number of neutrons.
Mm-hmm.
Very
That
easy.
easy.
equals
That's easy.
number of neutrons.
Yeah.
I'm much
Great.
better at writing on a line when I can see the line at my
Shall we give them an example?
Yeah, I bet we
Let's
can
do
All
it.
right. Let's go. You want to?
clear the writing.
Oh yeah, I guess.
Thank you, Mr. Henderson.
Yeah.
All right. So example number 1. How many neutrons are in the average cobalt atom?
Okay,
Okay.
so here's our strategy. First, we're going to get a periodic table and look up the mass number, and we'll have to round it to the nearest whole number.
Mm-hmm.
Okay, then we'll subtract the atomic number from the mass number, just like you showed us.
Very easy. There's
Okay.
only 2 rules that you
So
need to
let's
follow.
look at our periodic table,
Okay.
and we're going to find cobalt.
Where's cobalt? Who
In
can
the
tell me?
middle of the top.
Middle of the top. Fe?
Fe, no.
Cobalt. No. Right
CO.
here it is. CO. Now, remember, we're going to round this mass number to the nearest whole number. which
And
would
our
be-
students won't need a review of rounding rules, but
Yeah.
I'll just mention if the number after the decimal is bigger than
Then
5,
five.
we're rounding up.
All right.
Okay. And then we're going to subtract from that the atomic number, which is at the top on this chart, which is 27. And when we subtract that, it comes up to 7,221. Is that
Oh,
right?
At least.
Yeah.
Or
Oh, wait a minute.
32 for sure.
32 is exactly
Okay.
it. Yeah.
I was
okay.
going to grab my calculator.
So
Okay.
cobalt has 32 neutrons and 27 protons.
Right.
And together they add up to 59.
Yes, that's the
Yes.
atomic.
There we
Great.
go.
So we got it. We've
And you see-
answered our question.
There we are.
Okay, let's try another one.
All
I
right.
wrote this in a different format. This is called isotope notation. So basically it tells us the mass number and the atomic number for this particular isotope of gold.
Yeah.
Yep.
And if you've got this isotope, bring it to me. I accept bribes.
Okay. Yes, me too. Okay. Now,
Yeah.
this time they have it kind of nice because up here is your mass number, down here's your atomic number.
Mhm.
So I'm just going to subtract those two.
Right.
7 minus 9. Oop, can't do it. We got to
No,
borrow, right?
Gotta borrow. I don't like subtraction when you have to
17 minus
Yeah.
9 gives me an 8.
borrow. Mm-hmm.
8 minus 7 gives me a 1. 1 minus 0 gives me a 1. So we have 118
Which is the number of?
neutrons.
And we'll see what these numbers stand
That's
for.
the mass
Mass
number.
number.
Mhm.
That's the
Atomic
atomic
number.
number.
We subtract them and get our neutrons.
There
Oops.
we go.
So no matter what form it's written in, we know what to do.
All right.
Okay, there's one more subatomic particle.
That's
All
the
right.
one I was asking about earlier.
Don't forget the electrons.
Right.
Okay.
Right. The electrons. Well, let's see. Negatively charged, what we say right here. What we're
That's why
saying
it's
that
an
right
E
there.
minus.
That's
Yeah.
right. Okay.
Okay.
It has a negative charge of what? What do we know?
-1.
Okay, yeah.
With the right arrow.
It is
Oh, there you
found
go.
outside the nucleus, kind of hovering around wherever you want to call it.
Yeah.
Right.
Okay.
Why would it stay around the nucleus, though? What do you suppose? If we have a positively charged proton,
Mhm.
then the electron's going to stay because opposites attract.
Oh yeah,
Right.
because protons
But
pull.
it's not going to fall into the nucleus because it's spinning around at such a fast
Yeah.
rate that it won't do it. It's kind of like taking a yo-yo on a string and swinging it around.
Mm-hmm.
Okay.
All right.
And their mass, it says, is almost nothing, but Mr. Henderson knows our exact number.
All right. And the mass of it is 1 over 1,836. Very small mass.
Very
That's
small. That's
yeah.
almost nothing.
Yeah.
So
that's the
that's
end.
all that we need to know about 3 different types of subatomic particles.
Yep.
And
Very
don't forget
easy.
about Dalton and Democritus.
And
Make
there'll
sure
be
you're,
more.
yeah, make sure you're going to memorize at least the atomic theory.
Yep, the 4 stages there.
Right, and those
Yep.
of you who haven't met Mr. Henderson yet, he's in G107,
Yes.
106.
106. You're in
I'm
107.
107.
And
Yeah.
I'm 109.
Yeah.
So
109,
you know where
yeah.
your chemistry team is. We'll all help you with any of the material.
Exactly.
Absolutely,
Anytime,
anytime, any day.
All right.
All right, thanks guys. Have a good one.
Yep.